My name is Renato, and today I'd like to talk about the challenges and the option as well to run a relational database on the cloud. I say, I'm Renato, I'm Italian, I live and work in Berlin, and I work as a principal cloud architect for Funambol, a provider of private cloud solution, white label solution for mobile carriers. When we come to a conference like this one, there's many topics we talk as DevOps. We talk about, of course, at the moment a lot about Docker, containers, orchestration. Of course, we always want to have every system highly available. We like to talk about autoscaling, serverless option. Is it better to use autoscaling? Is it better to use serverless? Or those kind of paradigms. And we talk as well a lot about data storage option like S3 on Amazon, or in general as infrastructure as a code. And they're all very nice topic and very important topic. There's one that we talk a bit less about, and that's usually the data storage in terms of a relational database. And the reason why it's important is that, well, it's often your bottleneck. You might have a beautiful web application that scales amazingly. You might have auto-scaling in place. You have your Docker containers, or you have whatever you want, serverless function or whatever. You scale, everything scales automatically. You have full automation on front end, back end. And then somewhere down the line, unfortunately, there's a relational database because we might still need it, or maybe because some key data are there. And that one doesn't scale that well usually. So before going through the option, let's see what kind of issue we usually have when we play with relational databases. If you think just about running a database, MySQL, for example, on a simple virtual machine or on your computer at home or whatever, you have certain limitation and certain topics you usually have to deal with, from basic issues relating to the engine itself, like for example connection limits that you need to configure on your configuration, you might need to adapt. When you start to be in production, you might have as well some networking issues, because of course you still, whatever, even if you hide the complexity of your deployment, you still have somewhere a server running the database, a cable somewhere. And the more data you throw it, and at some point you might hit some limitations. You might have as well some provisioning issues that, what do I mean by provision issues? Is, well, everything works great, but suddenly your disk is full, or anyway, you allocated originally, I don't know, 200 gigabytes for your database. Suddenly you decide that you need 200 gigabytes more. It's not that straightforward and immediate. It's not just a one API call usually that takes a few milliseconds to double the storage and provision more resources to a database. We'll see a few examples in a second. You have as well, of course, scaling issues, because, well, in a very simple way, even if you go to cloud services, you can usually scale very easily vertically, change the instance, change the virtual machine you are using, adding more CPU, adding more cores or whatever, but still at the end of the day, at some point you hit some limit and you have to start to think about, are you going to replicate your data if your load is mainly read, so maybe you're able to, with some read replica to handle it, or if you need to start to introduce sharding, and all those technologies are not that easy to integrate in your DevOps deployment. And as well, when you think about infrastructure as a code, when you think about trying to describe your deployment in a real world, whatever you use, something like Terraform, or whatever you're on Amazon, you use CloudFormation or something like that, you want to have something that you can version, something that you can reliably describe how your deployment is. But it's not that easy to describe a MySQL engine with its own configuration and how you're going to change it. How do you describe your policy to scale it up or scale it down? And even when you think about upgrading your, we're using the example of the web application, or anyway, whatever product you have, you might have all those nice, beautiful paradigm, like you want maybe to use blue-green deployments and say, okay, I'm going to use blue-green deployment. They're perfect on the cloud. Amazon has been promoting blue-green deployment architecture since, I think, their first reInvent event in Las Vegas years ago. And yes, I mean, the cloud is perfect to go blue-green, so duplicate basically what you have, just point to the new deployment. You can do it at the load balancer level, you can do it at your autoscaling level, you can even do it at the DNS level, change the entry point. You have some advantage, some disadvantage. You can talk 1 hour, they talk 1 hour, actually multiple hours about the topic. How do you actually include or exclude from your blue-green deployment your data layer, almost a relational database? Well, out of a 1 hour presentation, they go down to probably 4 or 5 minutes about how you handle the relational database. And at the end, there's nothing new there, there's nothing magic. They tell you, well, ideally, your new system should work on the whole database. If you're lucky enough. Otherwise, you should be able to decouple your changes from the database to your product, of course, and either have that the old product is able to run with the new version of the database, or the new version of the product is able to run with the old version. Anyway, somehow decoupling changes to your schema, for example, doing some before, some after. All that is not straightforward. It's not that easy to manage in a production deployment. It's not as easy to write, I don't know, a few scripts to have an auto-scaling in place or have an elastic number of backend running. And in this talk, I'm going to focus a lot about Amazon AWS, mainly because I'm working 80% of my time on that. But most of the topic actually apply to most of the cloud providers. The option you have to deploy a relational database are very similar on all the major cloud providers. So these examples are going to be mainly on AWS. I'm going to use the term Amazon and AWS more or less as a similar term, even if they're not, and using MySQL. So when you think about MySQL on the cloud, you have basically 3 options. Option 1 is you do everything yourself. You think about using a virtual machine and one more Docker. You can do whatever you want, but you have your own installation of the database. The second option is to use something that the cloud provider provide for you, where they run the MySQL engine for you. And the third option is usually something more cloud-oriented, that is some kind of fork of the original open source database that the cloud provider, wherever Google or Amazon, has forked and adapted to their own specific requirement to either provide some more automation or to provide better performances or claim to provide better performances. So let's see quickly those options. So very first option is to run your MySQL engine on a EC2, on a virtual machine. So you have full control of your engine, you have full control of your database. You rely, of course, on some volume. You need to store the data somewhere, most likely on some EBS. You have, of course, full control, so you have root access. You can change whatever you want in your configuration. You can deploy the version you want to have running on your database. You have full flexibility because, of course, you can choose the kind of instance you want to have, the kind of operating system you want that the engine, your database runs. And of course, you have already some advantage of the cloud, because even if you do it on the cloud, you have easy, what I call easy vertical scaling, in the sense that, well, you can adapt your deployment according to the load you have. So if you have a single server running and suddenly you realize that you need more resources, you might be able to just get a bigger instance, more CPU or more memory. And at the same time, if you over provision at the beginning, you can still scale it down. So you have already some extra benefits of being on the cloud. But with all this flexibility comes as well many limitations. And if you want to have full control of it, that's perfect. But otherwise, you have to, of course, like for any production environment, you need to set up your own replication. So it's not anymore to just run one virtual machine with MySQL running. You might need to set up your slave. You might need to set up your few read replica if you need read replicas. And you need to decide how you're going to do that replication. Are you going to do it asynchronously with the open source version of MySQL? If you want to install something else, do you want to run it with Galera cluster? It's all up to you, but you have to manage it. One thing to notice about running your own database on a virtual machine is that's usually as well the only option you have when you have a very specific requirement. So let's say, for example, on Amazon, if you want to run not the MySQL distribution, but a Percona fork, a fork from Percona. Maybe you're familiar with Percona as a MySQL option. Well, the only option you have is to install it yourself, or anyway run AMI, a distributed version of that, but you have to manage it yourself. There's no other option. Same as well if you need to run a very old version like 5.0, or if you want to run the very latest general available release, that is MySQL 8, the only option you have at the moment is to run your own virtual machine. There's nothing else. There's no service in the cloud that support it yet. So on a pure architecture point of view, if you have your backends talking to something, you have to think about having, here is very much simplified, but anyway, you have a master, you have your own slave, that probably gonna be a synchronous replica somewhere, one or more the read replica. You have as well to take care yourself, of course, of the failover. How you're gonna manage the failover is up to you. To simplify that, since on Amazon since more or less 10 years ago, there's now as well a managed version of MySQL. They call it managed and scalable MySQL is RDS, and in that case is a managed service. What does it mean, a managed service? Means that basically still the original version, if you're running, I don't know, 5.7.23, that's the version you're running, and you can choose that version. But basically, you don't have access anymore to the operating system. You don't have any more access to the file system. They run it for you. They pre-configure the most common parameter for you. You have a basic, quickly to run configuration. And you have no full access to the database anymore, but you have some advantage. We see which one. Again, you have vertical scaling as you had before, so you can choose how you scale it up and down according to what you need. And you start using managed services on the cloud to have some advantage in terms of replication, for example, on those tasks that maybe if you think about developing your own product, maybe you're not that keen to have to manage replication, backup, and point-in-time recovery, and all those things that are really part of a DBA adventure, but they're usually not what you want to do on a day-to-day basis. So using something like RDS offers you the option to avoid those steps. What does it mean? The replication is done by Amazon. In this case, it's done, it's transparent to you. You don't even know how they do it. You just know it's synchronous. So it's not the standard open source asynchronous replication provided by MySQL. It's something, it's a fork, it's proprietary, you have no visibility of the code. But again, you have a master and a slave. The failover is managed by them. So the way failover works from your application point of view, you just have a endpoint, you have a CNAME, and database failover when something goes wrong. If you are okay with those couple of minutes of downtime that you might have, or anyway awful latency, and you can manage it at the level of your application, that might work. And on top of that, they provide a lot of APIs. So everything you don't manage it anymore going on the machine yourself, but you just make API calls wherever using SDK, whatever using command line, whatever using other services. So you can start to integrate a few things. You can start to have automatic backup just with a simple API call, or point-in-time recovery without having to think yourself how to recover data when something goes wrong. In this presentation, I'm focusing on MySQL, but there are, of course, other engines as well available with very similar limitations. So you might want to run Postgres, you might want to run Oracle. Again, certain versions are supported, other versions are not supported. And going back to the example before, so you're basically replacing those instances that you were running yourself with a service. So a step forward with some disadvantages as well. Next step is instead using something that is not anymore standard MySQL. And in case of Amazon is called Amazon Aurora. That is basically a fork that they did of the original engine. Is claimed to be compatible, is MySQL compatible. You can choose which version. So, for example, they support 5.6 and 5.7. But you don't have any more visibility about which exact version of the product you're running. You don't have, for example, specific bugs that you want to see if they're addressed from the open source version. They're not there because it's not anymore that engine. Again, you have vertical scaling. You can choose with API calls what kind of resources you want to allocate. So if you want to have spend more, basically, and have more CPU and memory, and as well, then you can scale up and down according to what you need. Here, the big difference is you're talking now about some proprietary technology, so you don't have anymore. It's not anymore an open source project, and with some benefits as well in terms of performance. The storage layer has been optimized for the cloud, whatever that means. And in terms of the topic of this talk, you start to have a one step forward. It's not anymore that they manage the service, but for example, one of the things that you have to manage yourself, for example, to decide how to allocate storage to a database, that for example on RDS, you still have to say upfront how much storage you want to have. So let's say I start my project, I'm going to production, I have to guess how much storage I need to have on my database, and the storage affects as well the performance of my read and write. So in case of Aurora, you don't have to guess anything anymore. The storage starts with 10 gigabyte and keep increasing on 10 gigabyte according to how much you use. It keeps increasing. So if you empty the database, it doesn't increase, but that's, you remove from the complexity of your deployment something. So you don't have to manage the storage yourself anymore. The replication is not anymore a master-slave with the visibility that you had before of the failure. Is hidden behind. There's they guarantee you that the data is replicated in 6 different well, actually in 3 different availability zones in different data center, but how it's done is none of your business anyway, you don't know. But how is that going to affect the real problem that is automation? I mean, my goal as a DevOps is I would love to have my backend and as well my database run as my autoscaling group or whatever else, that I don't have to think about it. It scales up and down whatever I need, and it does it automatically. So let's think the very simple case. Let's not even think about I need to do sharding, I need to do read replicas, I want just to, I have my little simple web application that has some traffic in certain hours of the day or certain days of the week or whatever. I want to scale it up and down according to certain metrics. I want that the engine of my RDS, I'm using, for example, RDS, I want that it's not anymore that I go to the console or call some command line and I change the instance, but I simply want that it happens automatically. How can I do that? Well, there are simple ways to do it. In case of Amazon, is okay, I can use a service like monitoring. There's of course a monitoring, so you can use in this case CloudWatch. CloudWatch shows you certain metrics, and you might decide, even I'm doing here from the console for simplicity, but you can, of course, the most normal way is use either Terraform or something, or whatever tool you use. You can use Bash, command line, SDK. You might create certain alarms. You might decide, okay, I want that this system notifies me when my production database is, in this example, I'm using over 50% of CPU for more than 3 by 5 minutes, more than 15 minutes, and I want that it goes in status alarm when that happens. Okay, I can then trigger something. I can say, okay, this one is going to notify, in this case, SNS, so a notification system, and I want that that notification system triggers, in this case, a serverless function, so a Lambda function, and the Lambda function is going to change my database. So it simply is going to say, okay, if for more than 15 minutes my database load is over a certain threshold, I want that I'm assuming here the database as a slave as well is a multi-AZ in the case of Amazon, so that I can do it live. It changed the instance type, and address it provides more capacity basically in terms of memory and cores. And I can do that as well for other metrics. I can say, okay, we say that, for example, on RDS, the storage has to be handled manually. I can say, okay, but if I have less than 10 gigabyte, I create my own Lambda function that does the same, emulate that approach, and I can increase the storage. And I can do that on many different metrics. I can do it that on CPU, I can do it that on the latency. Basically any matrix that is exposed by my own database, I can do some logic. I don't even have to, in this example, I was using Lambda because, okay, that way I can claim that I don't even have a single point of failure. I'm using something that is highly available, but I can actually even use just an instance, a virtual machine, create a simple cron with a bash script that does the same, or in the language that I want. Using a SDK, I can do the same. I can implement my own logic and trigger some changes in my database and try to scale my resources up and down. I call this one fake autoscaling. We'll see in a second why I call it fake autoscaling. But the very first question you should have is, Well, if I can do that with simply a Lambda function and a few notification, and I can even do it redundant, why is not available out of the box? Why the major provider actually don't provide that much in terms of scaling up and down your database in an automatic way? Well, before going to a few examples where we see why that is usually a bit of a problem, is I have to think as well what the role of the DBA is in all this. This is a slide, actually is a picture from one blog post from Amazon about 1 year ago, where they claim that basically the role of the DBA has entirely changed, entirely shifted from spending most of the time on the platform and managing the access to the operating system and monitoring and whatever it is, with very little time on the application layer. Now is the exact opposite. I don't fully subscribe on the story in terms of, for example, I see big difference in terms, for example, of monitoring, but I can definitely see that as you have on something like RDS less control of the operating system, of the installation itself, of course, if you choose that way, you most likely want to focus on something else. That is, of course, the database schema and the application and what kind of queries and what kind of issues you have in the production database. But let's see, when I say that is a fake autoscaling, let's see what happens when you have something goes wrong. So we said before, I have my web application. Maybe it's nothing going wrong. Actually, I'm just hit by a lot of traffic that I didn't expect or whatever else, but my front end is scaling without problem, my backend is scaling without problem, my autoscaling is triggering new instances, and everything works fine. Unfortunately, somewhere behind I have my database, and someone is calling me, and well, the database is not scaling. Why is not scaling? Well, think about when you want to modify a database. First, let's see what we say when we say before we want to scale it up and trigger some modification. This is just a subset of the console. When you want to modify a RDS, for example, you have 10,000 different options that you can modify all at the same time. You can change the parameter group. That means change the parameter that affect your MySQL instance. You can change how much the instance type, so you can effectively say how much memory you're going to allocate. You can change even the instance class. Sorry. And you can change the storage or the provision IOPS. So you can change many different aspects that affect in different ways your database. And hopefully you try usually to improve the performance of your database. You might even think that is a kind of panic button. Okay, we say it's 3 a.m. or whatever time you find most inconvenient to be waking up that something is not working. Probably your CTO or the CEO is calling, saying, what's going on? What are you doing to fix it? And very unlikely you're going to try to find on RDS or whatever other managed service what's the root cause of what specific query or what specific problem is affecting your database. You probably think, okay, with my auto-scaling fake scripts or whatever else, I can simply scale it up. It's low cost because I claim that I can always scale it back. It doesn't really always apply. For example, you cannot easily scale back the storage. So once you have increased the storage, the only way to scale it back will be to dump your database and create a new, usually most the cloud provider. But it's quite a tempting option. I mean, you have something that provides more resources to the database. Why not? I mean, the database at the end is suffering. You have nothing else you can do than either just wait and look at the console or look at your metrics and hope for the best, or apply some change either automatically or manually. Well, the problem with that approach is that when you introduce, for example, a new instance in an auto-scaling group or a new container, whatever, it's a matter of quite light change to the entire configuration, and usually it's quite seamless and it takes a few seconds. In case of a database change, what you're really doing is with your API change, you're really just, the API change might take a few milliseconds or a few seconds worst case, but technically, you're just saying, please apply those changes to my database. And from that moment on, you have no control anymore of your database until those changes are applied. You're basically telling someone else, whatever is, hopefully not a person, someone on the back end that is doing the job, some automatic script that are going to change those things for you. And you cannot change it back. It's not that I can say, okay, now I want to scale up with my auto-scaling script, and in 15 minutes, while it's still doing the modification, I'm going to call it back and say, oh, actually, no, that's not what I want to do. I want to do something else. No, you have to wait until it's done. And you're paying for it. I mean, of course, you're paying more resources, and you're as well paying maybe in the long term, because we said if I double the storage of my database, I might not be able to call it back easily. And I might be tempted, because I don't know the root cause of the problem I have, to apply multiple changes, because maybe different metrics are in error in a specific moment. So the problem we saw is you might be tempted to think that when you apply multiple changes, everything happens simultaneously, or you're saving time. Why not, for example, doubling my storage and the CPU at the same time, as I still don't know what's going on and it's quick? Well, the problem, for example, in Amazon is those changes don't happen simultaneously. They apply them sequentially, usually. So they might apply first a change in the virtual machine, then do a failover. So of course, if you have a master and slave configuration, so multi-AZ, what happens is technically they apply a change to a slave, a failover happens, there's a new master, and they apply the same change to the new slave. The problem is, if you have multiple changes you're asking in a single API call, what happens is they're doing multiple fallback between the master and the slave, or a master and even a new slave, because, for example, to allocate new storage might be an entire new slave. And you have no easy way to predict the order of those changes. I mean, it's not anyway defined in the API what's happening first. You might guess it from certain tests, but it might change tomorrow. And this is an example of a database suffering, for example. It's not even a very big one. It's an extra large M4 going to a 2 extra large, doubling from 400 gigabyte to 800 gigabyte. The entire modification took 12 hours. And for 12 hours, going back to, you're not able to do any more modifications to that database. Only 13 minutes required the change to the instance type, and almost 12 hours was actually changed to the storage. So for example, if the root cause was actually the trigger, either IOPS was, for example, actually the bottleneck was the instance type, you would be better off just doing the change in the instance type and have your database available in a very short time. But still you might wonder, okay, there are no risks. Worst case in that time is as good as before. Okay, I cannot call it back, I cannot say I'm not going to change it again, but my script is still okay. I mean, I wait, at some point will be better. For now is as good as it was when he had problem. Well, unfortunately not really. I mean, let's take one of very common cases for a database. Is my MySQL is running out of IOPS. So my storage cannot handle the load anymore. I need to provide either with, in case of Amazon, provision IOPS or standard IOPS or whatever. I need to provide more IOPS, otherwise I cannot write to that database. That means usually means that, for example, of course, my latency is going up on the queries, and quite easily, unless your application is very well decoupled, it's quite easy to see with even not that great latency, the application entirely going down. And okay, so now I have think about that script we were writing before. Now I think, okay, the script is ready. I applied the script in production, and so my database is running out of IOPS. I changed the storage automatically. I doubled the storage. Well, what's the issue with that? You can see it in the console. In the console, they give you some warnings. Of course, when you use automatic script, there's no warning. It's part of life. But like in this case, if I'm doubling from 400 to 800, or 300 to 800, whatever, they tell you two interesting information. Is basically, as soon as you run out of the first burst of IOPS credits, you should expect quite long conversion time, because basically what happened is your real life traffic you have on the database when you have issues is going to compete with those operations on the database in terms of IOPS. So, and the second one is there's an impact on instance performance until that operation complete. If you put those two together, they're basically telling you that it might take really long and you might suffer for quite a long time. If you add it with the third information, that was you cannot change that notification back. Actually, the only thing you can do at that time is delete the database. That is unlikely what you want to do. You start to see that it's not as simply as increasing your autoscaling group. It's not that easy to have automatic scripts on RDS, for example, to scale up easily a database. And that's as well why it's pretty hard as well for the cloud provider to provide those transparently. This is a similar example. Instead of using standard IOPS, I'm using just provision IOPS that are more expensive, more flexible, that I can remove them. So still, even if maybe the conversion time is going to be shorter, but still there's still impact until that happens. So it might be as well that if, for example, you had a spike that was just due to a burst, like maybe because there was an event or something else that for a few hours your traffic goes up, you might actually serve better that traffic doing nothing and waiting and apply those changes at a later stage, schedule them for low traffic hours the following day, then really apply them immediately with a script in an automatic way. So in short, even with RDS, even with Aurora, you might still have to be quite careful how you handle the automation. Now, we said at the beginning, I want to, ideally, if I think about a database, my dream will be to have something like I have for other components. Don't even have to think anymore about a server behind. I want to perform certain queries. I want, in an ideal world, I don't want to think about what's running behind. I don't want to think behind as a server size with, I don't know, 8 gigabyte, 22, 24, 32 or whatever, how many CPU or whatever. I just want to perform my queries and have capacity according to what I'm doing. And that's really not what the cloud provider offers until today. So in case of Amazon, that has quite a lot of option, even just RDS is offering at the moment, yes, it's offering you a lot of flexibility, but you have like, even in the shortest, in the region with less option, you have 27 plus different instance types. And that's already quite a lot to handle to figure out what's best for you. Yes, you can do a lot of testing to figure out what's best for your database, but it's still quite a lot. It's not just a vertical. You should choose which one is more memory, which one is more optimized for IOPS and whatever else. And you have different engines, you have different instance class. It's pretty hard to decide how you're going to scale it up with your scripts or with your auto-scaling logic. In that direction, there's something new, for example, in Amazon that is called Aurora Serverless. The name is great. It sounds wow. Reality is it's not there yet, but they're going in that direction. Basically, it's an endpoint without an instance type. So when you fire, it's now about 2 months that has been available. It's not in preview anymore. You have an endpoint without an instance size anymore. So you don't choose anything. You just choose, you have a CNAME. It scales easily. You pay per use. What does it mean you pay per use? Means that basically is a bit similar to the concept of serverless functions, so of Lambda. You integrate it as well with IAM roles. So instead of using the specific authentication of the engine, so in this case MySQL, you can integrate with the authentication of the cloud provider. So in terms of, for example, of Terraform or integration or whatever tool you use, is much easier to manage it. And this claimed to be, again, MySQL compatible. The idea is that you are able to use, you don't use APIs to make the queries. You still use a JDBC driver or DBC driver, whatever you use today. You should be able to use it on that scenario. How does it really work? Well, again, the complexity is hidden behind, but basically, if you have no traffic, there's no server running. The first query might have latency, of course, that is a bit higher than what you usually expect in the database and can be up usually in the region of 5 seconds. If your kind of application can handle that, it might work, otherwise it might be. So it's definitely not suited for every kind of use cases. Is that really super exciting? Is really going to cover the entire serverless approach in relational database? Not really yet. It's a step forward. There are definitely scenarios where that works really well. If you have, for example, really unpredictable load in the database or a very new application that you want just to test it, because again, you pay just when you use it. You don't have any more a database always running. You just pay when you make queries. And if you have, for example, a good caching in front, and you should have it in front of your application, of your database, maybe as well the 5-second latency on the first query is not that a big deal. It's great for development testing because, of course, you can, for example, have a copy of your production database running just when you need it. So you have still pay the storage, but you run the database itself only when you need it. And in general, for anything intermittent, where you have intermittent load, or for as well, for example, tasks like if you have weekly reporting tools or tools that need to run just occasionally, that's an option as well. In terms of the full picture of are we already able to say that instead of running a standard MySQL engine with a visibility of the engine, we are now able to just run a serverless version and everything was fine? Not there yet. I mean, for a large production database, that's definitely not a solution, not just for term of course, but in terms as well of technology. So we are still far from being able to sit down, relax, and enjoy the view on the relational database layer, at least. With that, thank you, and I'm open for questions.
Thank you for your speech. I have, on the one hand, serverless is a pretty cool and awesome solution, but on the other hand, you have to you provide your expertise to another guys. I mean that your team should not your team doesn't have any knowledge about how to tune database and so on. It means vendor lock-in. You can't just move from one cloud provider to another. How to deal with it?
You raise a very good point. I didn't mention the vendor lock-in. That is a very good point. That's the big difference in the different layers. Of course, the very first step is when you run with just virtual machine. Of course, there's no vendor lock-in. You can move out the way you. Well, there's always the challenge to, if you have large amount of data, what is technically feasible. It might be not something that is cheap enough to do to move out. That's kind of always a challenge. But when you move towards, of course, RDS, you still have you give up some of the freedom. There's no way around it. But you still don't have a full vendor lock-in because, for example, on RDS for MySQL, you can still run easily an external read replica on a virtual machine or an entire endpoint outside Amazon. And I replicate on that, I promote that master, that as a new master, I'm out of Amazon. That's up to RDS. I can do that on Aurora up to a point. But again, I'm in vendor lock-in mode in the sense that I'm not anymore on a fully compliant MySQL. I'm running their own version, so you might have challenges there. And of course, the more you go towards technology like serverless, you are giving up a lot in that sense because yes, it's true that you're still using your JDBC driver. You're not changing the nature of your product. You can still replace them with something else. But I tend to agree with you that in terms of you're giving up some of the freedom to go towards something that is ready to the cloud. At the same time, you have certain advantages in doing that. But in most scenarios, for at least MySQL, you are able to take it out. If you then means that you are going to do it and how challenging, because the problem as well is usually the team that has reached that point of integration is a team that gave up a lot in terms of DBA team because they didn't want to manage themselves a complex database. So to get out, usually you need that knowledge. It's not just they don't let you do it. Technically, they let you do it. You then need to be able to do it. That's a very different topic. Yes,
thank you for your answer. If I understand correct, you mean that serverless not for everyone. It's
definitely not for everyone.
Sure.
No.
Thank you.
Oh, thank you. So as far as I understand, we are not there quite yet for the relational databases in the cloud. So is this true for other databases? I mean, is there some solutions for NoSQL by the providers like AWS or other guys?
Well, there are definitely not, well, in terms of not relational databases, definitely yes. I mean, there are no relational databases that has been designed for the cloud. Like Amazon went straight with Dynamo, and that's their solution. Other cloud provider provides something else. If you are in that scenario, it's great. Then the topic of the vendor lock-in is fully there, because you're not using anything compliant to anything. It's their own technology with their own API. It's a bit like when you use S3. At least there became kind of the de facto standard, even if I don't like that they find the standard, but basically every other provider is trying to implement S3-like APIs. But if you like use Dynamo on Amazon, you hardly go out of Amazon. If you want, you might need to migrate your data in different ways. So yes, and then there's, well, in terms of Google, there were other options as well. And there are as well SQL options that are certain cloud providers decided as well to go the way of changing the language. Basically, you like to provide certain functionality to give up certain aspect of the language. So that's again, you're a bit in vendor lock-in mode, and so there scenario where it makes sense, scenario where it doesn't.
Okay, thank you.
Thank you for the speech. And my question about not the cost of your speech, but maybe you have some experience and can answer. You mentioned about blue-green deployment and database schema, related with database schema changes. And imagine that you already switched to green line and have some changes related with that data, and something happened. It doesn't matter what exactly happened, but you decided to switch back.
Yeah.
What you do with data changes that happened between that period?
That's actually a very good point. Is that that's usually quite that's part of the problem of managing that one in terms of splitting the changes before and after. But technically, okay, you probably start to have to, okay, you start at T0 when you switch your database. You probably have you should have a point in time copy of the data at that time. So in case of RDS, you probably have done a backup API call. That means that it's going to be done at that specific time. Then you switch to the new environment and you decide to switch back. So how you handle your clients, how you handle your latency, if you were doing it at the DNS layer or whatever, let's forget that for a second. Let's think just about the changes. You probably go back to the previous. Either you implement logic to go back, that you are unlikely to do, or you go back to the original data and you have to replay all the changes that happen from the user perspective in that time. How that is going to affect you in terms of downtime or in time of recovery, it really depends. To me, at least, it really depends on the project and how sensible are those data. And the very first, I guess, in that scenario, the very first concern is data loss. Even the recovery time is less vital. But
okay, it's understandable, but sometimes we have changes that cannot be recovered. Just imagine that you delete one property or one column and create new column and have changes related with that. How to you?
So you're saying I delete? I delete column A and I introduce column B in the after the changes to the product, and I want to go back.
Yes.
Yeah, that's I will.
Transaction between of releases.
Yeah, you basically need to first to handle them separately. One is the how you handle column A, the data that was in column A, and how you handle the new data in column B.
I mean, if you have some time and you switch it to green deployment and nothing happened, maybe 1 hour and more, and something happened after that, and you decided to switch back. And you have new changes related with deleted column and related with new column, and decided to switch back. How you deal with that situation?
Well,
I also think the same, but maybe you
Well,
have
it's not really
experience.
no way. I mean, the column you you dropped one column, so that one you are going to reintroduce it, and you don't even have to reintroduce it because you most likely are going to go back to the database frozen at that point in time, and the data column is there. And you're going to introduce the new column, whatever we call B, and you probably don't need it anymore. Now you have two problems: how to populate the data of column A, and that really depends on the transaction you had in that time, but you are able to replicate the logs of your database from that time 0 to the time 1. So you can handle that. You might not be able to handle it immediately, but you might be able to reprocess that log as those API calls and figure out what you need to do to go back to that scenario. The new column, if that data, best case scenario, the new column, you don't need it and you don't need the data that is there. If instead in that column you have data that need to go back somewhere else, well, then is a migration process. You need to do it, I think, ad hoc. That's the only way I will do it. Well,
Okay, thank you for your answer.
but yes, you are in the worst case scenario. I still think the first question, because I entirely forgot about talking about vendor lock-in. Thanks for pointing it out.
So, Renato, thank you for your fulfilled and deep presentation.
Thank
now
you for
we would like
inviting me.
to hand you the certificate of the participant and the
Okay.
small present.
Oh, thank you very much.
And would like to say you a lot of thanks for
Thanks.
your presence here.
Mhm.
So
Thanks.
it was a great honor to meet you here in Russia on the DevOps conference.
Thank you very much.